In the next 8 minutes, you are going to make a program that controls this LCD using your Arduino microcontroller. Hi, my name is Jeremy, and welcome to the 9th tutorial in a series of videos aimed to teach the basics of using an Arduino microcontroller so that you may compete in this semester's Solid State Circuit Society Arduino contest. More information available in the link below. If you have not already, check out our previous videos, as this one will build on their material. An LCD, or liquid crystal display, is simply a more advanced version of our 7-segment display covered in the last tutorial video. This LCD is made up of 2 rows, where each row can display up to 16 characters at once. If we zoom in on a single character, we see it is made up of a 5x8 grid of pixels. So, whereas a 7-segment display uses 7 pixels to represent any number from 0 to 9, an LCD display uses 40 pixels to produce numbers, letters, and even custom characters like this smiley face. Now, with 40 pixels per character and 32 characters in total, we must control 1,280 separate pixels. How could we possibly control all these pixels? Well, it turns out we only need 16 ports. Beginning at the bottom, the first 2 ports supply power to the display and must be connected to 5 volts and ground. Moving all the way to the top, we have 2 backlight ports. The backlight is effectively just an LED light placed behind the pixels that illuminates the screen. Just like a normal LED, we can connect the positive side to 5 volts and the negative side to ground. But remember to add a resistor of around 250 ohms to avoid burning out the LED. Then, in the middle, we have 8 data ports, an enable port, a read-write selector, and a register selector. These 11 ports will be controlled by our Arduino and used to set the 1,280 pixels. Finally, the last is a contrast port. This port effectively controls the brightness or contrast of each pixel. We will connect this to the wiper of a potentiometer so that we can adjust it later. Let's build the circuit. Remember to disconnect your Arduino to avoid damaging any components. Then, take your LCD display and place it on the breadboard as shown. Connect the bottom 2 ports to 5 volts and ground. Then connect the top 2 backlight ports in the same manner, but remember to include that resistor. Next, we can connect the 11 control signals. Today, we will only be writing to the LCD. As such, we can fix the read-write signal to ground. Furthermore, we will only need the upper 4 data ports, so we can leave the other 4 unconnected. Finally, connect the pixel contrast port to a potentiometer as shown. Next, let's write the code. Today, we will create a simple program that displays the text "Hello Arduino" followed by a nice smiley face. To help us do this, we will make use of the Liquid Crystal library. At the top of your code, type #include liquidcrystal.h. Then, define the 6 control signal ports. These port numbers will depend on how you hooked up your LCD. Next, define a variable we will use whenever referring to our display. I will call it LCD, but you may use any name. Type liquid crystal LCD bracket and then attach your port definitions with port RS for register select, port enable for enable, and ports D4, D5, D6, and D7 for our data ports. Then we will configure our display. The LCD I am working with has 16 columns and 2 rows of characters. So, in the setup function, type lcd.begin 16:2. Next, we will display our message. Move the cursor to the top left position with lcd.setCursor00. In this function, the first number specifies the column and the second specifies the row. For my LCD, the column can range anywhere from 0 to 15 and the row from 0 to 1. Then type the message with lcd.print hello Arduino. Next, let's create a smiley face. To tell the LCD which pixels to illuminate when drawing this custom character, at the top of your code, add a variable. I will call it smiley face, but you may call it whatever you like. Type byte smiley face square bracket 8 square bracket equals, and then in the brackets put 0 B and then 5 zeros, comma, and copy that line 8 times. By doing so, we have created a binary array of size 5 by 8. Each bit in this array corresponds to a separate pixel. So, to set the on pixels, simply change the 0 to a 1. First, I will draw the left eye, followed by the right eye, and finally the smile. Next, in the setup function, create this character with lcd.createChar bracket 0, smiley face. For this function, the first argument sets an identification number for the character, and the second specifies our pixel settings. Each custom character you add will require a unique identification number. Next, let's display the smiley face. For fun, let's move our cursor to the center of the second row. Type lcd.setCursor 8, 1. Then display the character with lcd.write and in brackets put byte followed by a 0. And you're done. Plug in your Arduino and upload the program. Then adjust the potentiometer until the letters become visible. If successful, you should see the text Hello Arduino displayed on your LCD, followed by a nice smiley face. If so, then congratulations! Feel free to play around with the LCD display. I challenge you to make a more advanced version of our last tutorial's stopwatch. Program your LCD to count up and then add a push button that resets the counter whenever pressed. Join us next video when we will learn to make music on this piezo speaker.